Hello everyone, welcome back. Today we will be entering chapter 3, which is on momentum and impulse. In this chapter we have, I don't actually remember, but I think we have 2 or 3 subtopics. Okay, so just 2 subtopics for this chapter. Alright, so the first subtopic is on the chapter, which is momentum and impulse itself. So in this subtopic, you need to be able to define what is momentum as well as impulse. And then you have to also be able to solve problem related to impulse and impulse momentum theorem. And then use the force against time graph to determine impulse. Right, so now what is momentum? Well, momentum, the linear momentum, which is the symbol is P, of an object of mass m moving with velocity v is the product of its mass and velocity. So in short, momentum is the product of its mass and velocity, ataupun the product of mass and velocity of an object. Okay, so mathematically we will be calculating the momentum using this formula here, where P is the momentum in kilogram meter per second, m is the mass, and v here is the velocity. So again, we have scalar and vector quantity, and momentum falls in the category of vector quantity, so it will have a direction in which the direction is the same as the velocity punya direction. Okay, so as per usual, vector quantity can be resolved into x and y component, such as this one lah. Okay, alright, let's go to the next theory, which is impulse. Now impulse is defined as the product of force and time. Okay, so just now momentum is product of mass and velocity. Now impulse pula, impulse kita guna J. Impulse is the product of force and time. Okay, so the unit for impulse is kilogram meter per second as well, ataupun Newton second. Okay, both can be used, both are considered as SI unit. And then impulse is the same with momentum, in which it is a vector quantity, and the direction pula, it is the same with the constant force acting on the object. Okay, so when a single force acts on an object, the equation can be written as shown here. Okay, so this one is constant force. Okay, the force is the same. Okay, so by changing the momentum of an object, it requires the application of force. Okay, so the change in an object's momentum is actually equal to the constant net force. Okay, so if a question asks you to find the net force of an object, but they only give us the change in momentum and time interval, this is how you calculate the net force. Okay, so Newton's second law of motion describe about the rate of change of momentum. Okay, Newton's second law of motion. So if the force of an object is not constant, just now yang di sini ni untuk constant force. But if the object is not constant, we can integrate the force in terms of the first time, and then it goes to the second time. So we can actually find the average force. Okay, we can find the average impulsive force. So this is the vector quantities for both impulse and momentum. However, we are only considering for 2D collisions only, so we are only looking at Jx and Jy. Okay, so the Jz we won't be considering in this matriculation punya syllabus lah. Okay, so when two objects are in collision, we can see this graph here. The shaded area under this graph is giving us the impulse lah. Okay, so this shaded area is this telling us about the impulse, right? So that is on impulse, and that is on subtopic 3.1.